Chunk-based RAG treats every document as an isolated island. A chunk about Alice knows nothing about a chunk about Bob, even if Alice manages Bob's department. And that relationship is the answer to the user's question. GraphRAG connects the islands. It extracts entities and relationships from your documents and stores them in a knowledge graph. When a question requires following a chain of relationships across multiple documents, GraphRAG can answer it where standard RAG cannot. There is a class of questions that chunk-based retrieval handles poorly, questions that require following relationships across documents. Who does Alice report to and what projects are they running? Standard RAG finds the Alice chunk and the manager chunk separately, but has no representation of the manager's relationship between them. GraphRAG stores Alice, the manager, and the manager's edge as first-class objects. Traversing one hop from Alice directly surfaces the manager and all their associated data. A knowledge graph stores three things: nodes representing entities such as people, companies, products, and places, edges representing relationships between those entities, and edge labels describing the type of relationship. The sentence Acme Corp acquired Betaco in 2023 becomes two nodes and one directed edge labeled acquired with a year attribute. Once stored as a graph, we can ask who did Acme acquire and get Betaco instantly without any embedding comparison. We use spaCy for named entity recognition. After loading the English model, we pass our text through the pipeline and inspect the entities. spaCy identifies Alice as a person and Acme Corp as an organization. For relationship extraction, we go one step further and use dependency parsing to find the verb connecting two entities in the same sentence. The word manages in this sentence connects Alice and the engineering team as the relationship label. We build the graph with NetworkX using a directed graph. Each call to add relationship creates two nodes and one directed edge between them. The edge stores the relation type and the source document it came from. The source attribute is important for citation. When we retrieve context from the graph, we can tell the user which document the relationship was extracted from. Adding thousands of relationships from across your entire corpus builds a connected map of your knowledge base. The graph traversal function takes an entity name and a hop count. We use NetworkX's ego graph to collect all nodes within a given number of hops from the starting entity. For each edge in that subgraph, we format a plaintext line describing the relationship and its source document. 2 hops from Alice surfaces. Alice manages engineering. Alice reports to Bob. Bob oversees product and engineering, and any other relationships within 2 steps. This structured text becomes part of the context sent to the language model. To combine graph and vector context, we first extract entities from the user question using spaCy. For each extracted entity, we call getGraphContext to traverse the knowledge graph and collect relationship lines. If the question mentions Alice and Acme Corp, we get graph context for both and join them. This gives us a structured relational context from the graph. The next step is to combine it with the semantic chunks from the vector database. The GraphRAG ask function combines both context sources. The relationship context from the graph goes first under a relationships header. The semantic chunks from the vector database follow under a document chunks header. The language model receives both and can use whichever is relevant to answer the question. For relational questions, it uses the graph context. For factual questions, it uses the vector chunks. Labeling the sections helps the model understand the structure of the context. You now know why chunk-based retrieval misses relational questions, how a knowledge graph stores entities and relationships, how to extract entities with spaCy, build a graph with NetworkX, traverse it for structured context, and combine that with vector retrieval for a hybrid system. In the next episode, we cover multimodal RAG, how to retrieve and reason over images, tables, and charts alongside text documents. Subscribe so you do not miss it. See you in the next one.